Now that we have a ChirpStack LoRaWAN gateway with us up and running, this is how the view of the ChirpStack application looks like. Inside this Applications tab you can see the node that I have created sending the data. We will create a LoRaWAN node with ESP32 and SX1276 based LoRa module. We did build some breakout boards for us to experiment with various LoRa modules. This is the PCB side for soldering the LoRa modules and connecting the spring coil antenna. This side we will solder the Berg strip for connecting the wires. This is how a soldered nice RF LoRa module looks like. This is the top view. Another RFM95W LoRa module we have soldered looks like this. They are based on SX1276. Now we will move on to the wiring between ESP32 and the LoRa module. You can take help of this chart to do the wiring. There are totally 10 wiring you have to do between the LoRa module and ESP32. Now that the wiring is down, we have connected directly using the jumper wires. This is how the setup looks like. We will move to the Arduino programming. For this code to work you need to install the library MCCI LoRaWAN LMIC library version 5.0.1 by IBM, Mathagis Koijman, Terry Moore. Copy the code from our website. The DevEUI in the code the same we are having for a node named ESP32 node and it is added in the ChirpStack. This same DevEUI needs to be entered in ChirpStack. Here you can see the same DevEUI in ChirpStack for the node. For the AppEUI and the AppKey you need to do the same. You need to set the keys DevEUI, AppEUI, AppKey. These are unique for each LoRaWAN nodes. Even if you keep them same, only one device will communicate at a time. If we click on our device on the ChirpStack and click for keys OTAA for the over-the-air activation, you can see the AppEUI and AppKey. This is the same that we had in the Arduino program. As a rule of thumb for setting DevEUI and AppKey should be unique, AppEUI is common for an application in ChirpStack. For the new node we will change the last 4 hex values to ABCD. We will change in the reverse order here, last one CD and second last one AB. Starting also we will change to 8 instead of 7 and make the change in hex format. AppEUI for the time being we will not make any changes. AppKey the last 4 hex values we will change to 1 2 3 4. DevEUI we changed in reverse order as it was little endian, but here it is MSB to LSB in the order of the hex values. Now we will select the LoRaWAN region. I am using US LoRaWAN region with 915 MHz. Also I have to select subband 1 as in ChirpStack the frequency hopping is limited to subband 1. Here we have set the transmission interval as 60 seconds. Now we will upload the code and once it is complete we will open the terminal to see the LoRaWAN transmission. So now our device is transmitting. We will add this device in the ChirpStack. We will head to Application section in ChirpStack, click on App, click to create a new device. I will give my device name as ESP_second_node, my device description as second node, and now I have to enter my device EUI. As you remember we changed first digit to 8 and the last digits to ABCD. Here I am using OTAA over-the-air activation procedure for the LoRaWAN node. Click Create Device. The name does not support space in ChirpStack. Once you click Create Device and it is successful, the keys page for the device opens up. I will open one more ChirpStack application instance in another tab and copy the keys from the previous device and paste for the new device and modify it. AppKey last 4 digits we changed to 1 2 3 4. AppEUI key we kept all zeros since I have already another node working with this EUI in the ChirpStack application, which will get affected if I had changed it. Click on Set Device Keys. Device keys have been created. Pop-up has come on the left bottom corner. Click on the Devices tab. You can see the new device we have created with DevEUI we have provided. Click on the device name and search for LoRaWAN Frames tab. Press Reset on the ESP32 while waiting for the LoRaWAN frames. We can see the data coming in. Join request. Join accept. Device Data tab. Also you can see data coming up. The device has been automatically assigned one device address, which changes each time the LoRaWAN device is reset and has a new joining over OTAA. If you are having trouble connecting, you can go back to the terminal of the Arduino and see the debug info. Here we can see the device connecting. Hope you enjoyed it. Stay in touch with us, like and subscribe as we go deep into LoRaWAN.